So for this benzocoin video, I'm going to be going over one of the problems I missed on exam 1, specifically question 5, part A. In this question, you're given a molecule and you have to identify the longest contiguous pi system in the molecule, as well as count the number of pi electrons in this pi system. So first, let me draw out the molecule. So you can see it's a 6-membered ring attached to a 5-membered ring. Sorry, that should be an oxygen right there. And then it's also got an oxygen in the 5-membered ring, as well as 2 phenyl groups coming off of the sides. So there you go. And then let's add the double bonds as well. Okay, so I think that's everything. So you can tell immediately that there should be some sort of a pi system here, because you see a bunch of double bonds separated by single bonds, which means that the electrons are free to move in between those double bond pairs. You can also tell because a lot of these atoms are sp2 hybridized, meaning that they're able to take part in a pi system. If they were sp3 hybridized, they could not do this. So we have to identify which of these atoms is involved in that pi system. We can immediately say that any set of double, single, alternating bonds should be part of a pi system, because that's essentially the nature of a pi system. It's a set of pi orbitals interspersed with sigma orbitals. So we can say essentially all of the 6-membered and 5-membered rings are part of this pi system, including the ones that have the phenyl groups attached to them. The phenyl groups themselves won't be part of this pi system because they're going to be not sp2 hybridized, but the rest of the pi system should consist of the 6 and 5-membered rings. This oxygen will also be part of that pi system because if you look at it, it should have 2 pairs or 2 lone pairs on it, meaning that one of those lone pairs will be part of that pi system while the other is not part of the pi system, because every atom can only contribute 1 pair of electrons to the pi system. So we'll circle that as well, and so we can count up the number of circles to get 1, 2, 3, 4, 5, 6, 7, 8, 9 total atoms as part of that contiguous pi system. And we can tell immediately that there should be no longer pi system than this in that molecule because it essentially incorporates all of the molecule. So the next thing we have to do is count the number of electrons in this pi system. So electrons to the pi system can be donated by either double bonds or lone pairs, which means that we should count the number of electrons from double bonds and lone pairs in these circled atoms. So within the circled atoms, we see 4 double bonds, as well as the 1 lone pair on oxygen, because remember, only one of those lone pairs is added to the pi system. So we multiply that by 2, so that's 4 plus 1 times 2, because each lone pair has 2 electrons. You get a total of 10 pi electrons in this contiguous pi system. So the answer to this question is that we have 9 atoms as part of the pi system, which contribute a total of 10 pi electrons.